I write a compiler for a simple operand-like programming language for the RISC-V architecture 32 bits. And now I'm going to look into the intermediate representation. And the first thing is that I want to extend the operand for the assembly instructions. So my assembly-like representation is called RTL, and this RTL kind, this is basically the kind of operands for the instructions, and one of the kinds is offset. Offset is basically a register with some offset. So each operand, the operand is this data structure here. Each operand has the value and value length, and value and value length are used, for example, for pseudo registers for the names. So character pointer at the length of the string, and the same fields are used as well for these offsets, so that value contains the register and length contains the offset. Instead of using the length for the offset, I want to add an additional field, offset, and save the offset separately from the value and length. I want to do it because I want to support these pseudo mem registers. These are registers, not registers, pseudo memory. When we allocate memory for local variables, for simple variables, we allocate pseudo registers. So these are pseudo registers that are later allocated and replace with real hardware registers, and pseudo mem is basically not for primitive types but for complex aggregate types like records, so that we do not just allocate a single hardware register but memory. But some memory for it. And for pseudomem, I need to save the name of this variable in this case and the offset. Therefore, both value and length would be already taken by the name of this variable, and we need an additional offset field to access an offset from this memory. This cannot be represented if we do not have this field, basically. I actually can just look for where this RTL kind used, kind offset, and this is for example the case here. And we also need to extend this set operand function then, which is a bit boring because there are a lot of usages of it, and I probably have to modify all of them then. But well, so we need an additional this set operand functions just sets operand values in one line. I can actually already write this on without this function, but I should assign one field per line, and I do not want it. The compiler is self-hosted. A future version of the compiler is not completely implemented, so some features are missing and I cannot use them in compiler itself. In a future version, I want to support record constructors, so to say, so that I can just write elna rtl instruction and then pass the arguments to it, for example, kind, and so forth. But we do not have this yet, and therefore I use this setOperand function. So let us extend this, or look at first this function. This function only allocates the memory and sets the operator kind. Yes, we need this function, and we need to add an additional argument to it, and I probably will move them into the next line, and we add operand offset here of type word, and then we can assign it to the offset field. And it should actually work. So the calls to this function do not pass the last argument, but it doesn't produce an error yet because there is no proper type checking yet. So this is done, and now everywhere where we call this function, we need to pass 0 as the last argument for the operand offset. And I think that I'll split the screen, and I will walk in the top half, and if I need to search for something in the source code, then I can use the bottom half. So yeah, just adding a 0 everywhere. Actually I can automate it, I think. Can we write, because there are really a lot of calls to this function, and we actually could handle it with a regular expression, I think. Tell instruction set operand, then we have a parent, and then we have a group with all possible characters. This won't work in all cases because there are probably cases where this function call is written in 2 lines, but we can try. So we want to save everything except a closing parent, and this doesn't find anything. I think that exactly this is for group matching. Now we match the first character after the parent, and we always have 1 or more characters, so I can set plus here, and it matches everything now. And after the group, it should also match the last character. Now we can replace this thing with elna RTL instructions set operand with two parents, and first comes the group and the second one is a 0. Yeah, that seems fine. Okay, I still want to go through all the calls to see whether I missed some invocation. For example, here, this is exactly the case that I meant. It's kind of strange, or of course I have to search for this one. Then we have this case. Okay, and this is done. We do a final test. Now we can look where the RTL kind offset is used, and we switch from the first argument to the third. Actually, this is wrong. The first argument of the offset should be the register. So here's the offset 0. We switch from this argument to this if it is used somewhere. This is the write function, and if it sees the offset, then it writes the value. This one should be replaced with the offset. So we write the offset, not the value. Oh, this is wrong. This is the register and offset is here. And here I set the offset from the stack pointer. We want to move it and probably split the call into lines. Then we have 0 offset from T1, and here we have in another case, so I split it after the offset. Oh, and here we want to do the same. So we write 0 here and remove the 0 here. I think I do it every time differently. Exactly, this makes more sense, I think. This is fine. So then we have this case. And we want to remove 0 from here and put it in here. The same. Okay, and here in another case, and that's it, I suppose. Okay, this is done. And I want to rename this offset kind. I want to call it memory. For the renaming, we will rename it here. And for the renaming in the code itself, this actually it isn't used this often, but well, we rename it with a regular expression as well. So I just look for the Elna RTL kind of set and rename it into Elna RTL kind memory. And we do a quick test. And this is fine. Now in the TSC generator I have an argument is address that tells us whether TSC copy address is actually not the right thing. I think I look where it is used. So the LNTSC designator is, for example, the left side of an assignment. the reference expression. Yes, I think it is only used in this, the designator and this TC copy address for whatever reason. TC copy address is called from the field access expression. TC copy address and array access expression. But it isn't set here. It is still set in the designator function because it is passed as pointer to this function. It is set, and then copy address just takes it as value. So we are interested in the TIC designator function. I go to the bottom half. This is this function, and it has this is address argument, and this address basically converts, for example, the designator, the left hand of an assignment expression, to a list of instruction and saves it somewhere, and it says whether the value we assign to whether it is an address or not. For the assignment, it should be whether it is address, whether it is an address or not, because we need it to generate further instructions based on that. And is address as value is not enough. We also need is addresses, for example, useful if I do things like assigning to a reference pointer, and now we also want to use it to assign to record fields. And for that we need to save not only whether it is an address or not, but also whether it is an aggregate type with some offset. And we need to define a new help type for that. And I will just call it LNTIC result. It will be a record, and instead of is address, let us call it the referenced pointer. As said, this is, for example, to assign a value to the reference pointer. So in this case, the is address will be true, and we can generate a store instruction. In the case where we assign to a variable, is address would be false, and we generate a copy instruction for the assignment. So the reference pointer, and it will be a word. It is actually a boolean, but I think that I do not support 1-byte values yet, so we say that this is a word, a 4-byte value, and the second value will be basically an offset if needed. Let us call it object offset and define it as word. LNTC result. And now we have to replace this argument in the LNTC designator. First of all, let us split this thing and put the symbol table into the second line. And here we say that this is a pointer to LNTC result. I'm actually not sure where it should be allocated. It should be allocated, or we can pass a stack variable to it, yes. So this probably will still work because we do not have type checking, and a word and a pointer to some object have the same size of 4 bytes, so there is no difference. And now we need to look into the callers of the LNTC designator, and this is the first caller, and it passes this is address variable, and as I said, it will be aggregate type now. LNTC result, we pass a pointer to it and look where it is used. For example, here. I don't like the reference pointer. So I will call it isAddress for now, but we will rename the variable later. So isAddress. I hope it is still the same function. Yes, it is. Okay, this is the second column, and here we will also say that this is an LNTC result. Actually, we do not have to check whether it is true or not. I hope. Exactly, then we have this is address. And this is already the designator. Field access expression. Assignment. And that's it, I suppose. Okay. So we go into the LNTC designator, and here we need to pass this variable to other functions. but we will do it in multiple steps, or probably I do not pass it. Yes, I always set it here, so it is kind of easier than I thought. I can just write this address here. So just add a field access. Okay, that seems to work. Then we wanted to rename this is address variable, because this address is a bit strange. So here it is fine, and here we have the unary expression. I can call it result. This is actually a type, or the type of the operand, or an additional information for the operand for the next argument. Yeah, let us call it operand type. I think it is a bit better. So is address here. Then here. And that's it, I suppose. Okay. Then we have the designator. Here we still have is address. We call it operand result as well. Not operand result, but operand type. And I messed something up. Operand type. Let us revert it a bit. Okay, the error as it seems is in this array access expression visitor. So operand, because I call it operand result. Okay. The renaming is done. And now what does actually the designator do? So as I said, if we have the reference expression that we don't do anything with it, but just set the operand type to the is address. Actually, is address is always set, and that's the first thing, because we do not set what was the second thing? Because we do not set the offset everywhere, we can set it to 0 here. Operand type, it was object offset, I think, and we set it to 0. I actually think that the operand that is address is set to false in the most cases. So here to false and here to true. Exactly, here we have field access expression. This is actually the thing that should be changed, I think. Here we set it to true for the array access expression, because array is accessed through a pointer, but we cannot use our object offset here, because the offset is not static but can be a variable. So an index is an expression and not a static offset. Then here it is false and here it is false. It is actually, in most cases, it is really false, and I can probably just set it to false. So let us remove these assignments and just initialize this thing. It is kind of more readable if we set it explicitly. I'm really not sure, but well. Operand type is true, false, and false. And here we have the field access expression, designator base type declaration. So field access expression on the syntax level can be two things. It can be a real field access expression, or it can be enumeration, because enumeration they look like field access expressions. For example, here we have the enumeration type first and then the enumerated value. So we are only interested actually in this case, and in this case I call this LNTC field access expression, and it probably calculates the offset. This function is called once, and it calculates the offset, and it calculates an add instruction that adds the offset to the value. What we are going to do, so this function gets a pointer to an operand. Does it return anything now? No, it doesn't. But we can return the offset from this function, I suppose. Let us add a return type to it then. And field offset is probably the correct thing, so we set it to 0, and then field offset plus field type. Slice, which isn't actually very correct, but well, all fields are 4 bytes long, or multiple of 4, but we should actually also think about the alignment. This isn't important in the current state. So we pass operand type is address to the LNTC copy address. Or does it have the operand type? No, it just calculates, just calls designate expression recursively. And actually we add here a constant value of the field offset. So the field offset is then the value that we return from this function. And then we can assign it here. So basically we say that operand type object offset is the result of this function. Is address is true isn't required anymore, I think, but we cannot remove it yet. Yeah, instead of generating this add instruction, we should calculate it later, but I'm not really sure. How to migrate from the current. Exactly here we check, for example, whether it is an address or not. Actually, instead of is address or not, we can also use an enumeration where we check whether it is an address or an object offset or nothing. Or I just say, okay, if operand type is address, then we do one thing. If the operand type object offset is greater, this is actually also not correct. Yes, we need an enumeration here. I cannot distinguish between a plain object and object offset by assuming that offset is not 0, because if we access the first field of a record, then the offset won't be will be 0, and we cannot distinguish it from a plain object. So we go to this ELNA RTL result. TIC result, not RTL. And we have here is address, and we define a new enumeration. Result type, result kind. TIC kind and TIC operand are already used. Let us call it operand type, and the values will be plain object, the referenced object, no, the reference pointer, and a sub object. These are 3 values that are supported, and then we will have this operand result. And here, yeah, this is the problem with the type, because type is a keyword, and then I cannot call a field. But first we need to rename this thing at all, so this NTIC result should be called operand result. And I probably move the symbol table into the previous line. NTIC operand result, operand result. Okay, this is probably fine. So now is address will be of type NTIC operand type, and offset will be just called offset. And I think that I already use it here. Now we want to rename this is address field. We will just call it kind. And I can just look for the is address access. Why it is still called is address here? This is unary expression. So we will call it kind. Where, so here I renamed it, then I just pass the value, and here I do the comparison, but I want to compare not whether it's null or not, because for the enumeration it won't be 0, because enumeration values begin with 1 in ELNA. So we actually need to check explicitly for the correct operand type value, which should be, so which should be the reference pointer, the referenced pointer. Then we have is address here. And this is actually the same. Kind is LTIC operand type, the reference pointer. Then we do load. And here we assign a false to it. That shouldn't be false, it should be plain object in the most cases. And it is the operand type plain object. And the offset is 0. And here we have NTC operand type, the reference pointer, NTC operand type, the referenced pointer, This case is interesting because we pass the enumeration value now, if I understand it correctly. So once again, where this NTSC copy address is called, once here and once here. And here I pass the is address, that should be the kind. And here actually to And this should be, of course, the kind as well. Copy address. And the type of this variable is basically LNTIC operand type, and we check whether it is LNTIC operand type, the reference pointer. I could also possibly do it a bit different with this NTSC copy address. I think I could just pass yeah, well, I could check here for the type. Nah, I think this is fine. So let us rename this address variable now. Operand type and operand type. Okay, this is the only case. Then we have this operand result. And we have this operand result here and here and here. And I want to rename other operand type variables to operand result. This is a different thing. Exactly, for example, this one. So just that it matches the type name. Operand result and operand result. This line is probably too long. Yeah. Designate pseudo operand result. And that's it, as it seems. For the field access, so for the field access I return, currently I just return that it is an address. And what instructions do I generate after that? So field access or TIC field access expression. I just return it further. And the caller decides then what it does with the operand. This is array access expression. And it does copy address. Then we have the assignment, and assignment does different things depending on the result. And then we have unary expression, and it should dereference actually if it is a dereference pointer, so an address, then it generates a temporary variable and loads the value at this address in this variable. Actually, for the offset, I think it will do pretty the same. So we need new instructions to handle this. We define two new copy instructions. So this copy just copies one value into another value, and we also need copy to offset and copy from offset instructions. Let us see, operator copy is used, for example, here, and here we generate one, and I have the destination as it seems as the first argument and source as the second one. I actually want to swap them so that the source is the first argument. The original argument position, so that we have destination as the first operand, is because of assembly. So I started the compiler with a single pass compiler where I just generated assembly, and therefore the operands is in this order, but I actually want to change that so that we have soils as the first argument, and here is this basically the same. We have assignee as the first argument and the assignment as the second. Since we have a working state now, I hope, I added new operands. This is the reason why it fails. Let us save the current changes before we change the operands order. And now Elna RTL copy, and I pass it as instruction. It is called only here, so we just need to replace, to swap first and second. That cannot be that difficult. Instruction operands so I set the operands in the RTL. For the RTL, is this the correct order? So we only need to change the original, the TIC operands order, and this is the last case. Okay, that should break everything, because it will generate wrong instructions, and it compiles here, but it shouldn't pass the final test. TIC operator copy. This is the first case, we already fixed that. This is the second case, and we will have here a problem with the get address instruction, because get address expects the operands in the other order. I'll just write down the function name so that I look into it afterwards. TIC copy address. We will return to this one, and for now we will just copy set operand instructions in here and in here, and here we will keep it as is, and here we will swap them and say that this is 1 and this is 2, and then we go to the next usage and basically do the same. I actually shouldn't forget about the semicolons, and these lines are also too long. Let us remove this empty line instead. And that's it, as it seems. And now I go back to this LNTC copy address, and I also change the order of the arguments for this get address instruction. Basically I can then remove these two lines and move these two lines to the end again. And then we need to look for the get address usage. It is used here once and also here, for example, and here we need to change the order. This is already done, and the last place is this one. I think that this function is also called only once, and here we basically do the same. So we pass the TIC instruction to this call, and I just need to swap the first and the second arguments in the source instruction. Oops. And here it would be the second one. And that should be it. And I think that I will stop here. So we haven't achieved this much with it this time, but we did some preparation, defined additional fields for the existing operands, and added new instructions to work with aggregate types that require a static offset, like record field access, and I will continue with the implementation of these instructions later.